Hi all. So once again welcome back to the linear control system portions of first module of KTU syllabus. So here we are discussing about the block diagrams. Okay. So a control system may consist of a number of components. So in control engineering, to show the functions performed by each component, we commonly use a diagram called the block diagram. So a block diagram of a system is a pictorial representation of the functions performed by each component and of the flow of signal. Okay, so such a diagram depicts the interrelationship that exists among the various components of the system. Okay, so the main three elements of a block diagram are the block, the branch point, and the summing point. Okay, so these are the main three elements of a block diagram. Okay. So first we are going to talk about the blocks. Okay, so in a block diagram, all system variables are linked to each other through these functional blocks. Okay, so the functional block, or simply a block, is a symbol for the mathematical operation on the input signal to the block that produces the output. Okay, that is this is the input A, and it is given to a block of transfer function g of us, and we are getting the output B as just this input is multiplied with this transfer function g. So B is equal to A into g of us. Okay, so that is the function performed here. So normally the arrows indicate the direction of the flow of signals. So the arrowhead pointing towards the block indicates the input, and the arrowhead leading from the block represents the output. So such arrows are referred to as signals. Okay, and we know that the output signal from the block is given by the product of input signal and the transfer function of the block g of s. Okay, so next one is the summing point. So this is a figure of a summing point. So we have already learned in the first portions, and that is in the closed loop system, we have seen an error detector. Okay, so the summing point will act as an error detector. Okay, so here we can see that in a summing point, two signals A and B are there, and based on the signals, based on the signs where the signals are coming, whether the signal is added or subtracted is determined based on the signs here. Okay, so here A is connected to the plus sign and B is coming to minus, so B is subtracted from A, so A minus B will be the output. Okay, if both are plus signs, we will get as A plus B as the output. Okay, and this is about the summing point, and next one is the branch point. Okay, the branch point, here you can see this is a branch point. Okay, so this is the main line. So signal A is multiplied with G, and we are getting AG, and simply we are taking another branch from here, so that the branch gives a value of A. So this can be used for any other function that we can multiply with any other blocks, or we can use any summing point in this line, like that. Okay, so this is about the branch point. So for constructing a block diagram, we can simply connect these three elements in various positions. Okay, so this is a figure of an entire block diagram of an armature control DC motor. So we can see it is a large one. So there are so many blocks are there. So just the inputs are multiplied with these blocks, and we are getting an output there. And here we can see a branch point is there. So this is taken as a feedback signal, that is the output is feedback to the input for error correction. Okay, so this is a feedback signal, this is a summing point. Okay, and we can reduce this entire block diagram. That is, suppose if we want to ask the transfer function theta of s by v of, that is Laplace transfer of output by Laplace transfer of input. Okay, so it is very difficult to find the values from this block diagram. So if we can reduce this block diagram, to such a level. That is, from this figure, it is clear that the trans function, okay, will be Laplace transform of output by Laplace transform of input, because only a single block is there. So B of s by A of s will give G of s. Okay. So likewise, we can reduce this entire block diagram, and based on that, we will get a reduced value. Okay, reduced block diagram, and simply we can find the trans function. Okay. So the block diagram reduction an important technique. Okay, it is used to find the overall trans function of the system. So the rules are framed such that any modification made on the diagram does not alter the input-output relation. So we can see that here, that the rules for block diagram are shown here. The first rule is combining the blocks in cascade. That is, two blocks are connected in series. So what we can simply combine these two blocks like this. Okay. So these two blocks are multiplied together, and we will get as output as A into G1 G2. So we can simply replace these two independent blocks with a single block G1 G2. Okay. And combining parallel blocks, if two lines are coming parallel to a summing point, what we can replace with that. Okay. So here A is a signal, so we will get as AG2 here, and G1 is a signal here, so AG1 here, so AG2 plus AG1. Okay, so A into G1 plus G2 will be the output. Okay, so we can simply replace the signal here, that is the arrowhead. Okay, the direction of the signal is same. Okay, both are in forward direction, so we can simply replace this entire blocks with the G1 plus G2 only. Okay, so that the output we will get as A into G1 plus G2. So both the signals are same. Okay, that is, if you are changing any, okay, if you are doing any changes in the blocks, the signal should not be changed. Okay, the output, the last signal should not be changed. So here you can see that the output is A into G1 plus G2. Both case that they are same. Okay. So the next rule is that it's moving the branch point ahead of the block. Okay. So if you are moving, this is the branch point. Okay, this is the block. So we are going to move this branch point ahead of this block, that is after this block. So we know that if you are doing any changes, the output should not be changed. The signal's value should not be changed. That is, we should get an output, two outputs here. That is, one line is AG and one line is A. So if you are moving this branch point after this G, ahead of this G, we will get it as the first one is AG, the second branch will also, okay, the second branch will also be AG. Okay, if you are taking a branch point here, it will also be AG. Okay, that should not be there. Okay, so we should get a value A here. Okay, so for getting that, we have to just add a 1 by G block in the same line. That is, we are moving a branch point after a block, we have to just eliminate the block from this line. So for that, we have to just add a 1 by G. Okay, that is, we are getting an AG here. So if this AG is multiplied with 1 by G, it becomes A. So we are getting AG and A is the signal. Okay, there is no change compared to the previous figure. Okay, and next one is moving the branch point before the block. If you are moving this branch point before the block, okay, so here the two signals are AG and AG. So after moving this branch point, we should get the two signals as AG and AG. Okay, so for that, if you are moving this branch point before this block G, we will get it as A only. It will be A only. Okay, so for getting it as AG, we have to just multiply a block. We have to just add a block G there, so that we are getting the output as AG and AG. Okay, AG and there is no change compared to the previous one. Okay, and the next rule is moving the summing point ahead of the block. If you are moving this summing point, this is the summing point, we will get as output as A plus B. Okay, so this A plus B is multiplied with this G here. This is the output. Okay, so if you are moving this summing point after this block G, what happens? Okay, the figure will be like this, but the line B will not get a chance to multiply with the G here, because the summing point is after this G. Okay, ahead of this G. So we should add an extra block G here in the same line of B. Okay, so that we will get the output as here it becomes BG, it becomes AG, so we will get as the output as A plus B into G. The two values are same. Okay, so the thing is that if we are moving the summing point ahead of the block, we have to add a G. We have to add a G in the line of B. Okay, and next one is the moving the summing point before the block. Okay, if you are moving the summing point before the block, what happens? So here the input A is multiplied with G, and it is just added with the line B, so that the output is AG plus B. Okay, so if you are moving this summing point before the block G, both the lines A and B will get a chance to multiply with the value G. Okay, so it should be like that. So for avoiding that G, we have to just add a 1 by G block in the line, so the value will be B by G. Okay, so this B by G is added together with A plus B by G, and if you are multiplying with the G, it becomes AG plus B. Okay, so the same output as in the previous case. That is, if you are moving the summing point before the block G, we have to add a 1 by G in the line B. Okay, and the next rule is interchanging the summing point. Okay, if you are going, if the two summing points are nearby together, okay, likewise here we can simply interchange the summing point. Okay, the output will not be changed. If you are just interchanging these summing points. If a block G is here, okay, if a block G is in between the summing point, then we can't interchange the summing points. Okay, so if there are any block or summing point in between the summing points, we can't interchange. But here in this case, if the two summing points are coming nearby, okay, we can simply interchange the summing points. Okay, so it can be proved like this. That is, here A plus B, and A plus B is the C is subtracted from A plus B, so A plus B minus C here. And if you are moving the summing point and here, and this here, it becomes A minus C here, and this you will get as the A minus C plus B, so A plus B minus C. Okay, and the next one is splitting the summing point. We can split. Okay, so sometimes there may be conditions that the three cells containing the symbols, okay, the sign symbols, so we can simply split the summing point like that. Okay, plus plus, we are taking a summing point having plus plus, and next we are taking a summing point having plus minus. Okay, and in this case also the outputs are same. Okay, and next one is combining the summing point. That is, if two summing points are like this, plus plus and plus minus, we can simply combine these summing points like this. It is plus plus minus. Okay, so here the minus sign, okay, minus should be here. Okay, that is in the lower block. Okay, so mistakenly the minus is placed here. This is the output. Okay, so A plus B minus C, in both cases the output is A plus B minus C. And next one is, and very important one is, that the elimination of the negative feedback loop. If a negative feedback loop comes, how we can eliminate that negative feedback loop? Negative feedback loop means we are taking the output and just given to the input for error detection. Okay, so if such a loops are there, okay, feedback loops are there, we can simply replace that loops with a single block of having the gain, that is transfer function G by 1 plus GH. So the output C by R will be, okay, C by R will be G by 1 plus GH. Okay, that is, G is the forward loop gain and H is the feedback loop gain. Okay, and the proof is, that is, we can from this figure we obtain that C as R minus CH into G. That is, this R, CH is coming here, so R minus CH, it is multiplied with the G, so R minus CH into G. Okay, so it becomes RG minus CHG, and just we are rearranging it as c plus ag is equal to rg, and we are taking outside c, so c into 1 plus hg into rg, so c by r becomes g by 1 plus gh. So we can simply replace this entire large block diagram with g by 1 plus gh. Okay, and elimination of the positive feedback loop, that is if the two signs are plus plus, so this is a negative feedback loop, that is the feedback is given to the negative symbol. Okay, if the feedback is given to a positive symbol, how can we can eliminate that? So we can simply replace this entire block with a single block of having the transfer function g by 1 minus gh. Instead of this 1 plus gh, it becomes 1 minus gh, that's all. So c by r will be g by 1 minus gh. So these are the basics of the block diagram reduction. You have to learn the rules first, then only we can simply reduce a large block diagram into a small one. So I hope it's very clear. So thank you.